It's been quite a while. I haven't made any video. So today in this screencast, I want to show you how to calculate the time varying market betas. So specifically, I'm going to make use of the data of prominent car companies. So what's the market beta? So it's the fundamental concept used in finance to measure the riskiness, the market risk of a particular company. So here the thing that we're gonna do is the time varying nature. So basically we're not gonna calculate a single value for each company, but instead we're going to calculate a time varying one. So to do that, first I just need to download the car data. So I'm going to load the Yahoo Finance and Polars library. So for our example, I'm going to use Tesla, Ford, General Motors, and BMW, uh, Audi, and Mercedes. Okay, so there are basically 6 car companies, and also we have the market indices of US and also Germany, which is DAX, right? And let me just load this, and then I'm gonna download the data from 2005 until the end of October 2024. So let me download the data. So yeah, we are done with downloading the data. So now I'm just going to arrange the data a little bit to make it proper to work with. Basically, I'm going to create a data frame. So in one column, we're going to have the data of each cars, so in long format, and in other columns, we're going to match the stock market indices for which a car belongs to, right? So let me run this one. And then I'm also going to download this stock market indices of Germany and United States. Okay, so now we have the index values of each country. So for visualization, I'm also gonna match the ticker names with the car names. For example, TSLA stands for Tesla. This is obviously Ford, General Motors, and Volkswagen. So we have also BMW and Mercedes Group. Okay, I'm going to join the data. So our final data is gonna look like this. So we have the date. So we have the closing prices for each firm or car company. So we have the stock market index of Germany and United States. So, and then we have the indices of each country. So what we need to do, or what we're gonna work with, is this stock return, so which I calculated in here. The stock return is just the percentage change over the closing prices of each car company, and also we get the market return, which is the index close of each car company. So I'm gonna save this data set in my folder. So now I'm gonna switch to R. I'm going to load some helper functions in here. So I'm also gonna call an estimate CAPM function. So I'm gonna show this this in a while as well. By the way, I'm gonna put the codes in description of the video as well, in case you wanna replicate something similar or you wanna get the time variant market betas for different applications. You just feel free to use them. So in estimate CAPM function, here I'm going to use the slider function, slider library, FIR, which is the parallel computation library, and also the typical tidyverse for data manipulation. So what this function is doing is actually as follows. So it's going to take a data frame and the variable number in the regression, because after all we're going to regress the stock return of each company on the market return, right? Something like this. Y is regressed on the stock return is regressed on the market return. And for each regression, we need at least one observation. So if our data has less than one observations, we're just going to replace it with an NA. Otherwise, we're going to run a linear regression, right? So we regress stock return on market return for our data. and then we get the second coefficient, right? Because the first one is gonna be the constant one, right? So this is the regular regression, right? Except that we control for missing values, whatever. And then what actually we wanna do is to get the time varying nature of it. So we wanna roll it over time. So we're going to slide period vector function. So our x value is going to take a data, and then I rolling part is going to be the month. I'm going to show you in a while, and then the period is going to be month. So here the function is going to call the estimate CAPM function, which is written here, right? And then the regular inputs, right? And then finally we're going to return a table, which is a data frame, right? So this is our function. So I'm gonna come over here. So I call my function. So let's first see how our data looks like. So I'm gonna read the CSV file. Okay, so let's just minimize it in here. Okay, so let's do it from beginning. So here we have our data frame that we calculated in Python. So I'm going to convert the date into date format, because here it's in character format. Sometimes, I don't know, for some purposes the data is not called properly. And also I'm going to create a month column, because each time we're going to roll the data over 1 month. So if I run it, so it's going to be something like this, because here if you see, so it's just going to, instead of the daily data, it's just going to be 1 month. So let's choose the necessary columns and then drop the missing values. So it's gonna look like this. So we have a particular car company, so we have the date, so we have the month, so we have the stock return of each car company, and we have the market return, right? So let me just assign this value to our data frame. So this is our data frame that we're going to use. So here I'm going to use the nest function. I don't want to use the loops. Instead, especially if you have a lot of companies, it's better to use this nest function. So if I nest this data, you see, so it just groups the data, and then for each car company we have a different data frame, right? So you see the format, like the of this data column is changing. Instead of a double, now it's a list. So for each car company we have a different data frame. So what I'm gonna do in here, so I'm gonna call the future map, so which is actually the parallel version of this map function in R. So what it does, it just gets the data which is in here. So in data column, for each row, right, it's just going to call the roll CAPM estimation. So we are going to provide regular inputs in the function, and then for each car company, over time, it just rolls over the data and calculates the market betas. So I'm gonna run this betas daily, and then once you call it, you see again here we have a list, and in each list we have the results stored in here. So to get the results, I'm gonna unnest the data. Remember, here we nest the data, and here I need to unnest the data, and then I'm gonna just choose the car company, month, and also the stock market beta here. Maybe here I should choose, okay, let's maybe before choosing, because I also want to call the let's also put company here as well, because for visualization I also need to put the names. Okay. Anyway, so I get my market beta in here, okay, you see my estimated data frame now has more than 1000 rows, right? So basically for each company we have estimated betas over time, right? So now I want to visualize the market betas of car companies. So let's just get our data, so which is in here. So first let's put the density. Okay, so this is overall density of the betas, so they are roughly close to 1. So if I wanna do it for each car company, then I put this in here. Okay. So for example, if you look at the market beta of BMV group, so you see it's something very close to 1. And again, for example, in of Tesla group, it's on average a bit higher, 1.5, I would say. And again, for GM, it's slightly above 1. So let's do time series plots. If I do it in here, okay, now I think it looks better. Here we look at the let's make it 100%. So here we see that the market betas of Tesla group are especially volatile, and also they are larger in magnitude, right? So this means that the compared to other car companies, Tesla group is a bit more risky, I would say, but for other groups, they are rather similar to each other. So this is pretty much what I would like to say. So if you wanna support me, please do not forget to subscribe and also put the comments in this video. Thank you very much and see you next time.